Hi, this is Jason from Effective Dashboards, helping maintenance and reliability professionals get the most out of Power BI. So welcome back to another video. This is video one of a series of videos that I'm going to put together that's going to be exploring availability and reliability calculations in Power BI. So in this video, we're going to be starting off by looking at the mean time between failures and the mean downtime. Okay, so let's get started by looking at some definitions. So we're going to first of all focus on reliability. So reliability, it's a measure of the continuous provision or the service of the machine, or it can be at a system level. And it really measures how long can we expect the machine to run for and deliver the function that it's designed, so pump fluids or provide power without it failing. Okay, so mean time between failure, MTBF, and it's calculated using the actual running time divided by the number of failures over that period of time. And then we're going to look at the mean downtime, and the mean downtime is really looking at how long does it take to actually repair the machine, and this is really from the point it fails to the point it's back in service again. Okay, now there is another measure here which is we're not going to look at because we don't have the data in this data set, which is the mean time to repair, which is the portion of the mean downtime that looks at how long it takes to effect the actual repair. However, when it comes to availability, this is the one that's important because this is the time it takes from the point in time when the machine goes out of service to the machine returning to service, including the logistics for delivering perhaps vendors and spare parts and approval of budget, as well as the time to repair the machine. Okay, so those are the two measures we're going to look at. We've got a little example here, a really simple example, just to kind of get our heads around what we're going to be calculating. So in this example here, the machine is going to be running for 24 hours, and we're assuming that that is the planned runtime of this machine. Okay, 24 hours, they're continuously running. And during this 24-hour period, we had an actual runtime of 20 hours, and then there was a planned downtime of 3 hours, but there was also an unplanned downtime of 1 hour. Okay, and that was a failure. That was an unplanned failure. So if we look at this example here, the mean time between failures, the actual running time was 20 hours. The number of failures was 1, so the mean time between failures here is 20 hours. Okay, so we're not including this planned downtime here. If we then look at the mean downtime, the actual downtime was 1 hour. Okay, so it's unplanned downtime we're talking about here. And the number of failures was 1, so the mean downtime is 1. So a really straightforward example here. We're going to look at other ones when we get into the actual data itself. Okay, so let's explore the data that we need to be able to calculate these reliability figures. So here it is here, fairly straightforward. We've got an equipment number. We've got, for each piece of equipment, we've got the start and the end date of the downtime event. There's no time element here. You might be able to have your data with a time element, and that would give you more accurate downtime between the start and end date, which is great, but we'll just, the concept's the same. The start and the end date of the downtime event, a unique identifier for each of these downtime events, and whether the event was planned or unplanned. Okay, so that's a really straightforward and simple data set that we're going to use as the basis for the future calculations. Okay, so here's that data in Power BI. We can see we've imported that. No transformations there, just made sure the data types are correct. And we can see we've got this query or table called event, downtime event list. There's also a dates table here. If you need to understand how to build one of these dates tables and why it's important, then I'll leave a link below. I'm not going to cover that in this video, but that's the two tables I've got, and they are joined together based on the date field in the date table through to the start date of the downtime event. Okay, so we're going to use the date table to filter the period that we're going to carry out the analysis over for each of these different measures. So let's get into Power BI and start to build in some of these calculated columns and measures that we need to support these reliability calculations. So the first thing I'm going to cover is the concept of a shift. Okay, so we need this to understand the planned running time of a machine. So here's two examples here. The first one, and this is going to be the one we're going to use, we're going to assume that a shift lasts 24 hours. It's 24-hour operations, and the machines are designed to be run for 24 hours. Okay, that's the planned running time. Now, during that time, in this example here, we had 20 hours of actual running time, we had 3 hours of planned downtime, and we had 1 hour of unplanned downtime. Okay, so we're going to use that as a basis for our calculations. However, I am going to build in the concept of a shift. Now, because we've got we're going to calculate the number of days, and we're going to filter on the number of days that we want to analyze the availability calculations or the reliability calculations over. Then what I need to be able to do is accurately calculate this planned running time. Now, if a machine runs, if we're going to be filtering over the last 30 days, then we need to make an assumption, or we need to define how many hours within those 30 days we would be expecting the machine to run for. What are the planned hours? So in this example here, we're going to use 24, but we can use 12, or we can use 8, or we can use 16. I'm going to add in a variable that we can use to modify that. So if it's 12 hours, then what we want to be able to do is for every day, we just want the planned running time of the machine to be 12 hours. Okay, in this example here, it ran for 10 hours, had 1 hour planned downtime and 1 hour of unplanned downtime, and the rest of it was non-operating time. We want to be able to make sure we don't count that as being running time or time that was unavailable or whatever. So that's one of the concepts we're going to start off with as we go and create the calculate columns and measures. So the first measure we're going to create is going to be a measure that's going to define the length of a shift. Okay, so let's create a new measure, and I'll just paste that in here. So daily length of shift. So our shifts are going to be 24 hours. This is where you would modify the length of a shift. So it might be 12 hours, 16 hours, 18 hours, 20 hours, etc. So we're going to leave it at 24 just now. So that's going to define the length of a shift each day. The next measure, in fact the next calculated column, is going to be a calculate column here, so a new column, which is going to calculate the number of hours of downtime for each event, okay, based on the start and the end date for each of the downtime events. So we can see here we've got the start date here, and we've got the end date here, and it's going to apply that shift factor to that. Okay, so if the downtime is for 10 days and it's 24 hours a day, then it's going to be 240 hours. If the downtime was for 10 days and the shift length was 12 hours, then it's going to be 120 hours. Okay. So we'll add that in. I just need to update this quickly. Okay, so we've got some comments here that you can use. I'm going to make this PBIX file available to you. There's some comments here, but I'll talk you through it. So the first thing, there's a few variables here that we use. The first thing is to calculate the difference in hours between the start and the end date of each event. So that's what this date diff function does. Next, we need to, in this data set, we need to put in a provision here that's going to allow us to still calculate hours per day if the start and end date is the same. Okay, now that could definitely be an example here. We don't have a time dimension in the start and end date for each event, and what we're going to do here is we're going to use an if statement here that says if this value here is equal to 0, then we're going to force it to be 24 hours. Okay, otherwise we're going to use this value here. So that's just basically to protect us from having 0 in here. We've got the shift length here, and then finally we're going to get the result. So the result is going to use two divide statements here. First of all, we're going to take the result, so remember it's a downtime between the start and end date. So we're going to take that number of hours there, and then we're going to apply a shift factor. Okay, so we're going to basically divide the number of hours in the day by this division of 24 by the shift factor. Okay, so basically it's essentially saying if the downtime is a day, or say it's 10 days, and it's 12 hours a day, then we're going to take that 240 and we're going to multiply it or divide it by the 24 divided by the shift, which is going to be 2. So we're going to divide by 2, which is going to be 120 hours. Okay, so you might need to just get your head around that. We've done an example here for you to look at when you're looking at this. But essentially we're applying this shift factor to each day so that we've got the correct number of planned hours and the correct number of downtime hours for each event. Okay, so that is the calculated column. So I'm just going to enter that in there, and we can go back here and we can see for each of these we've got the number of hours. Okay, some more than others, 24 hours there, 24 hours there, etc. Now if I go in and modify the shift factor here to be 12 hours, we can see that the downtime over that 2 periods from the start to the end was is only 12 hours because it's only one shift between the first and the second, so it's 12 hours. Okay, Ideally, you'd have a time dimension here, but this is the data that we've got, so this is how we're going to calculate it. Okay, so next we're going to start creating some of the measures that's going to allow us to calculate this mean time between failures. So let's start by looking at this actual running time. So over the date range selected, so this date range here, how many hours was the machine actually running for? Okay, so that's quite important. So let's go in and we will create a new measure. Okay, so the actual running time, I've got some comments in here, but I will just talk you through what we're doing here. So the first thing is we've got the shift length, okay, because that's quite important. So we've got to understand how many hours each day we are used to calculate the planned downtime, the planned running time. And in essence, what we're going to do here, the result is going to be the number of hours in the period minus the downtime in the same period. So if I look at the period is going to be the number of days between the start and the end of this date selection slicer here. And then we're going to apply that shift factor. Okay, so if that number of days is 10, and the number of shifts, the number of hours per shift per day is going to be 24, then that's going to be 240 hours that we've got as our time between the start and the end date, or that date range. And then we're going to subtract the downtime over that same period. And then the net result is going to be the actual running time of the machine. Okay, now the downtime we're going to subtract is going to be the planned and the unplanned downtime. So let's go back into this measure here. Let's open it up. The second variable here, so the first variable is this shift length. The second variable is going to be this values statement here. So values returns a table of all of the columns that you actually define as the parameter here within the filter context. Okay, so the filter context we've got just now is going to be on date. So it's going to return a table with all of the dates between these two dates here, including those two dates. Okay. So that's going to be our table. Then we're going to use another variable, so we're going to look at the number of hours in that period. So the number of hours in that period, that values range here. So we're going to use sum x. Sum x is going to, first of all, take a table. So that's the table here, which is this list of values. And then for each entry in this table, we're going to add in the daily shift length. So whatever that happens to be, 24 in our example. And then we are going to sum up the total of this daily shift length over that table. Okay, that's going to be this this value here. Then we're going to find the downtime. So we're going to use that downtime for the event column that we created in the last part of this video. And again, we're going to use sum x, and we're going to go through the downtime list of events in the current filter context. And now, because we've got a filter, a join between the date and the start date, it's going to look at all the events that have got a start date within that period, and it's going to sum up the number of the downtime hours for those events, and that's going to get us the total downtime. And then finally, the result is going to be the number of hours in the period minus the downtime, and that's going to net out to be our actual running time over that dates selected. So hopefully you can follow that along. It's fairly straightforward. You might need to go through it a couple of times. I've put some decent comments in here as well that should help when you're starting to build this up yourself. Okay, so I'm back on the visualization here, and I've filtered this for just this one piece of equipment there, P1000, so I'll minimize that for just now. And I'm just going to build up this table so we can start to focus in on the calculations and see it being built up. So this actual running time here is 16152 for this machine, and just to check that that's working, let's reduce that by 1. Okay, and we see that it's reduced by 24 hours. So 16128 to 16152, yeah, it's 24 hours. Okay, so that seems to be working fine in terms of generating that number of hours. So the next thing is the number of unplanned downtime events. So it's a fairly straightforward calculation here. So we're going to count the rows of of a table, which is basically created using this filter function here, and it's going to filter on the downtime event list for all the downtime events which have got a unavailability reason code of unplanned. Okay, so that's going to give us the number of events that have got a code of unplanned. So the value we've got here when we add it into this visualization is 13. So let's just double check that. So I've gone in here and I've applied a filter here, and the dates are between the 1st of the 1st 2019 and the 31st of the 12th 2020. We've got a filter on unplanned and we've got a filter on equipment there, and we can see at the bottom of the page 13 rows are filtered, so that seems to be working just fine as well. Right, now finally we can actually look at the mean time between failures, because we've got the actual time the machine ran and we've got the number of failures. So let's go and create that. So it's a fairly straightforward measure here. It's really just dividing the actual runtime, date selected, by the number of downtime events, unplanned downtime events that is. Okay, and then measures we've already created. And then we'll just pull that into here. And we can see it's 16,152 divided by 13, and it's 1242.46. So I'm just going to nip over to Excel and just verify that calculation is actually correct. Okay, so within Excel here, and we can see 16,152 divided by 13 is the 1242.46, which is the same as this. Okay, so it looks like it's working fine. Next, we're going to go and create the mean downtime. So let's look at this calculation here. Mean downtime. Unplanned downtime divided by the number of unplanned events. So we've got this number of unplanned events. We don't have the unplanned downtime yet. So let's go and create a measure that's going to calculate that. So I've just pasted it in here again, and we have got, basically we're using some X, and we're going to go and apply this downtime event for our downtime for event hours. So that's that calculated column that we've looked at before. So we're going to go and filter the table downtime event lists for all of the rows where the unavailability reason code equals unplanned. Then we're going to add on this as an extra column, and then we're going to sum up all of the hours here, and that's going to give us a sum of all the unplanned hours within the filter context. Okay, because that filter context is, again, it's going to work on anything with a planned start date anything with a downtime event start date within this date range here. So that will give us that information there. And then we can go and calculate the unplanned downtime divided by the number of unplanned downtime events and get the mean downtime. So let's create another new measure. Okay, so we've got another divide statement there. So it's a downtime, unplanned downtime, and it's divided by the number of downtime events. Okay, so that is pretty much it. There's a little bit of an explanation there about the mean time to repair, and which is slightly different, but this is the one we're going to calculate just now. And then let's pull that into here. Okay, so 33.23 is the number of hours, the mean downtime hours. So let's again just calculate that to make sure that it looks okay. So we need to bring in here. Okay, so what we're looking for here is basically the number of unplanned downtime divided by the number of unplanned events. So it's this value here, 432 divided by 13, and we've got 33.23, which is what we've got here. So that looks great. That seems to be working fine. So just as a summary, what we've got here for this event here, its actual time it ran was 16,152 hours. Over that period of time, it's 13 downtime events. So the mean time between failures for this period here is 1,242 hours. The downtime for over those 13 events is 432, and the downtime, or the mean downtime, is 33 hours. Okay, so let's just tidy this up a little bit, just for a little bit of information. So I filtered it in this one. This is really just to keep it simple when we're actually building up the actual calculations and the values. But we can take this off, and then we can see here, we can perhaps sort it by the, by mean time between failures. Look at the number of downtime events. So let's sort by mean time between failures. Lowest. So actually this P1000 is actually the one that fails most frequently. In terms of the downtime, this one's got the biggest downtime here. So you can start to slice and dice it and analyze that information. It's probably worth hiding these totals here because they don't actually mean anything. This one does, because that's accounting the number of downtime events, but this type of stuff here is not particularly relevant. So we can go and hide those totals. And the other thing we can do is we can add in another table that filters and shows the downtime events for each one of these. Okay, so I've added in a table here. I could add some other visuals and stuff like that. And at the end of this video series, I will actually create a dashboard with all the information, but I really want to just go through the calculations first of all and get that information to you. So in here, we've got this table here, which I've just added on a filter there. So we're only looking at unplanned downtime events because that's all we're showing counting here. So if you want to see these two, you can see those. And then you can filter. And perhaps within each one of these, start looking at which ones have got the highest number of events, the highest downtime in terms of hours here. And then that would be what you'd go and actually investigate. So hopefully you found this useful. This is, like I say, it's the first video in a series of videos, but it's going to get you the mean time between failures and the mean downtime for machines that have got a defined planned running time. Okay, in this example here, it was a shift, which was 24 hours. So if you found this useful, it'd be great if you could give it a thumbs up. And if you want to keep up to date with the next videos in this series and any other videos I release, I tend to release one every week, then hit the subscribe button and you'll get a notification whenever I publish a new video. Thanks for watching, and I'll talk to you in the next video.